In this video, our team is going to present you the Google Cloud. So what is going to be on the agenda is it's going to consist of two parts. First part is going to be is discussed by me. So it's Google Cloud and its products. We will talk about the intuition, what is cloud in general, how it can be used. Then we'll switch to the Google Cloud, its products and services. We'll discuss the difference between GCP and Google Workspace. Then we'll dig into GCP more in detail, the major products of Google Cloud Platform, and focus on two specific ones, Compute Engine and App Engine, which we're going to have demos on. So the second part will consist basically of demos of these two last products, which can be presented by my colleague. Together we're gonna set up and create a GCP account. Then in the Compute Engine, we're gonna create and run VM instance, install and deploy Python script on the virtual machine. And in the App Engine, we're gonna create scalable Python app and deploy an Air Python app. So of course, all the links and the comments will be available on the slides so that you can all replicate the demonstration on your own local devices. Let's go with the part one, Google Cloud and its products. So what is cloud in general? So to give you a brief intuition, it's a remote on-demand available server or computer providing you with two basic services, data storage and computing power. Of course, via internet. So data storage, of course, that's the first thing when what comes to anyone's mind when they think about cloud. That's what we use from in everyday life, like storing the photos, files, videos, even in our personal Google profile. That's why I'll call it like household user knows about this, but about computing power and even more bigger opportunities of storing even bigger, massive data and dealing with it, running humongous codes. This part is, of course, captured by computing power, which is used all over in the corporate and professional, by professional users. So, all right, why do we need the second part? Why do we need the cloud for computing power, for example? So let's say you have an idea, you are a programmer, startupper, you run your own website, application, and you, for example, have the first users, customers. They can perfectly use your code as long as there is not so many of them. There are 2, 3, 5, 10 people. There's no problem. They can all access your website, and your website on your local PC is fulfilling their requests, is running perfectly. But then you have more and more. Imagine your website scales. You have more and more customers, more and more users. Then you have a threat of your local PC of crashing because so many requests are coming to you, to your machine, and running the code which your machine cannot sustain. So one of the solution is buy new one, buy three more PC, hundreds of PCs or like servers, and store them in your room. But of course, it's not feasible. So that's why you usually need a cloud service provider. If you are just a small startupper, you better use cloud service provider who can actually tailor the exact portion of the computing power to satisfy the exact amount of users that are using it. So basically, it's scalable instantly, whether you have a small amount of users or suddenly big amount of users. The load will be handled by cloud, which allocates to you to your application as much sources as needed. In addition, it provides some maintenance and other kind of support by the professional who works in the cloud service industry. So when we go to Google Cloud, what is the company and what kind of services it provides? Of course, this slide is meant to really scare you a bit, because Google Cloud has lots of products available for you in that cloud sphere. more than hundreds of products that we're not gonna cover in a day with you. So I will leave it as it is. Feel free to pause if you are interested to read some of those, but I will explain you just simply that Google Cloud can be divided into two major parts. It's the Google Workspace and the Google Cloud Platform. Google Workspace, you probably already know. Again, it's stuff that even usual people with just simple Google accounts have. It's, as you see by icons, it's Google Mail, Google Calendar, Google Docs, including the Google Sheets, slides, and so on. So that thing we're using, and even small companies are using till today. So this all cluster we can name as a software as a service. But of course, the major part, the juicy part of the cloud technology lays in the Google Cloud Platform. This is much more humongous area and expertise, which provides you an infrastructure for code running, big data storage, app deploying, and so on and so forth. So we're going to focus, of course, on Google Cloud Platform, which is much more relevant for our course. So let's discuss briefly our GCP major products. They can be divided into 4 clusters. First one is compute, then storage and databases, big data, and machine learning. In the compute part, we have also two biggest players, two biggest product is compute engine and app engine that we're going to talk more in the next slide, and we're going to have some demos about it. So compute engine briefly is just virtual machines that run exactly that are run on the Google Cloud servers, and you're just renting their computing capabilities, right, for exactly in the amount of how much you need. So this is pretty straightforward, simple. App engine is completely similar to the example that I provided at the beginning. It gives you scalable opportunity to run massive applications so that your computer, your server doesn't crash by using their very flexible, scalable server, which adjusts to the traffic. So this is very good tool for massive applications. And container engine and container registry, they manage the containers. We're not gonna deal with that in this presentation. And cloud functions, this is less as app engine, but for a smaller, more like single, they can be also called single function apps. So if you, for example, have very basic, like extracting from one database and putting it into CSV file or vice versa, mechanism code that is pretty time intensive, simple, but time intensive in run on your local machine, you probably need just cloud functions. But of course, for big apps, better use App Engine. Then there is storage and databases. In the storage and databases, we have, of course, Google Storage, cloud storage, which is just a drive to store all kinds of data. We're using it also personally, me and you, but of course here it's in the context of big companies. Big companies are storing their data in the big cloud storages. And then there are some different types of cloud storages, which one of them is Cloud Bigtable, which specializes on storing the NoSQL databases. So just to remind, SQL database, it's some database that has some relationship. So it's like interrelated database. So, but NoSQL, if there is no such a relationship, you can store it in the Cloud Bigtable. So there is some semi-SQL database, Cloud Data Store, and Cloud SQL, which already tells by its own name that it's for SQL databases. Then there is persistent disk, which is mostly used as a storage for our virtual machines, our VMs. And next we go to the big data. Big data, and of course it's BigQuery, one of the biggest products. It's a data warehouse for analytics. So basically you have lots of big data and there are so many that you need a really big computing power to analyze everything. That's where BigQuery comes into help. Then, of course, since big data is like so big and it's coming, like it's high frequency data, it comes every second, like every minute of every second, and you need to capture, process, and analyze this so-called streaming data. It streams like a current of water, like continuously. So it's all need a big machines to process them, and for them you need, of course, such a product as Dataflow, Data Lab pops up. So there is also a pioneer product of Google Cloud, the Google Life Sciences, which deals with big data on the topic of biomedical data. So like this is also pretty cool. Then there is machine learning section, which one of the products in this section is cloud machine learning. So Google Cloud provides you with some trainable AI infrastructure, which you can use as a user and tailor and train your AI, your machine learning model to do specific stuff. But of course, there are some already predefined ones, predefined APIs, for example, Vision API. It focuses on image data processing. There's Speech API. It specializes on speech-to-text transformation and vice versa. There's Natural Language API, which does text sentinel analysis, and Translation API does the language translation. So, okay, I told you I'm going to focus on Compute Engine and App Engine. So Compute Engine is, as I said, a customizable virtual machines. Yeah, this is a new word that I'm adding here. It's customizable, right? So the example where we need it, for example, we have to run a big lengthy code, which would take, like, I want to say ages, but weeks, for example, on your local PCs. Then you would probably need some more powerful machine. Again, you can buy extra computer with higher power or so, but maybe you just need it like for just for this code. Like, why would you need a whole PC, whole metal thing to run the code for a specific thing? You better probably rent it. And you can rent the computer capacities of the Google servers, where you can specify already memory and the CPU that you need. It can give you a range from half to 96 core CPU, and memory of RAM can be from 0.6 to 624 gigabytes of RAM, which is big range. You can choose any. It's fully customizable. Up to 64 terabytes of SSD, and so on and so on. You will see it on the demo how you can choose it by yourself. And of course, even if you chose really badly, the benefits of Google Cloud it provides, it also recommends you the right size after you use quite a while, and Google Cloud notices that this is too much or this is too little for what you want to run. They will recommend you the right size for it. And also it gives you uninterrupted experience during maintenance, which also provides very good, I think, comfortable experience with this product. Next one goes App Engine. App Engine does basically what I described in the first example where I gave you intuition. So example, you need to run a web application, mobile app, API, website, and you want to do it on the cloud because imagine you don't know, you cannot expect the traffic that's going to come. It's going to be suddenly big, suddenly small. There are waves of traffic activity during the day or in the long term. So all this thing is handled by the App Engine, by the servers that are, like, as you can see, they are scalable, they are expandable. They can expand or shrink whenever your code, your application gets very popular or gets not so. It will adjust in size. So benefits, of course, as I said, it install scalability. So it will run according to to the capacities needed. So and it will be instantly. It will instantly jump from if no one is using and then everyone is using, like you wouldn't even notice, the server wouldn't even crash or something. The Google Cloud app engine is ready to handle any type of overload in the system. And you also only pay for what you use. So it's also very good. Imagine your website is completely totally unpopular, nobody uses it. At least you don't have to worry about paying to the Google Cloud, because yeah, you will pay only whenever your application website is used, so only for the traffic. And of course, debugging and monitoring during use is also provide you extra comfort dealing smoothly and doing your own adjustments to the code. Like you can do it on the go, on the flow. So this is it. Now the juicy part starts, part 2, the Google Cloud Platform demo, which will be presented by my colleague. Again, try to practice it with him, and yeah, enjoy.
Hello and welcome to the second part of the presentation. In the first part of this presentation, my colleague gave you a general overview of the products and services offered as part of the Google Cloud Platform. What I would like to do now is to first show you how can you get started with the Google Cloud Platform. Namely, I will show you how can you create the GCP account. Second, I would like to talk about the compute engine. Namely, I would like to show you how can you create and run your first virtual machine, which you can freely customize according to your computational needs. I will show you how can you download and install Python on your virtual machine. And I will also show you how can you deploy some basic Python code on your virtual machine. Third, I would like to talk about the app engine. I would like to show you how can you create your first scalable Python app, deploy it to the Google server, and make it available to the whole world. To get started, what you would like to do is to first go to cloud.google.com, the website that I've got here. Click on Get Started for free. Wait until it loads up. It will ask you for your Google account and password, and then after some time, it will show the following page. So here, what you would like to do is to put your country. Here, I would say personal project. Have read, and click continue. It will ask you for your phone number. So after you have verified your phone number, what you would like to do is to put the type of account here. I would say individual. Put your name, put your address, put your billing information here. And you would like to click Start My Free Trial. As part of the free trial, you will get a $300 credit, which you can use basically to test for 90 days all the Google Cloud Platform products. So after you're done setting up your account, you will be redirected to the Google Platform main page, which looks like what you see on your screen right now. At this point, you're done setting up your account, and what I would like to show you is how can you get started with the compute engine. So what you would like to do is to first create a new project. Right now I already have the existing one, but for illustration purposes, I will create a new one. So click New Project, give it a name. So location, I would say I would just leave it like no organization and click Create. So after a couple of seconds, what you can see is the following, that you have a new project. You can select the project. Now you see that the main page has changed to the demo project. So what you would like to do now is to scroll down the bar on the left and go to Compute Engine right here. So after a couple of seconds, you've entered the Compute Engine, and on this screen you can see all the virtual machines that you set up previously. Right now I have none. So I'll go ahead and click on create instance. Right here, I would just say demo showcase, whatever. I will put the region, which is Frankfurt. And I would select the specification of the computer that I need. I would go to the smallest one for the illustration purposes. So I've got 2 CPUs and 1 gig of RAM, which is approximately going to cost me $10 per month. I would like to enable the display device. And here it's very important. I would like to change the boot disk, and in the operation system drop down, there are many operation systems you can choose from. But for this example, I'm going to show how you can run your virtual machine on Ubuntu. I will select the SSD disk and give it approximately 50 gigs of memory. Click select. Click allow HTTP and HTTPS traffic. And click create. So after Google is done setting up your virtual machine, what you will see is the following. So the new machine has been created, the status is okay. And what you would like to do is to go to connect and click SSH. This is the way to get your machine started. The new pop-up window will appear, which looks as following. So you would click connect and wait a couple of seconds until your machine boots up. So after some time, once Google is done booting up your virtual machine, you're all set. Your virtual machine has been created and booted up. What you would like to do next is to download the Python. But because there is no desktop experience available in this version of OS, you would have to operate using the console commands. For your convenience, I provided the console commands that you need for this project. So if you scroll down, you see that if we want to download the Python, we would need the following command. So I'm just going to copy that and paste it to the console command and hit enter. So I see that the Anaconda 3 environment is being downloaded to this virtual machine. So once Anaconda environment has been downloaded, we have to install this. And for this, there is a second command, which basically goes as follows. What you'd like to do is to replace this part of the command with the name of the file. So in this case, it's this part. So I would like to just copy that and paste it here. And hit enter. Hit enter once again. Read the license agreement and say yes. So it's asking where to install it. So I'll just leave it as it is and press enter and wait a couple of more seconds. So after the Anaconda 3 environment has been installed, you will ask if you'd like to initialize it. In this case, I say yes, hit enter. After that, I'm asked if I'd like to install the Microsoft VS Code. In this case, I say no. And at this point, you're done installing the Python. What you'd like to do is to actually restart the virtual machine. So I'd like just to close this window, say leave, go back to my virtual machine instances, and hit SSH one more time. So once the virtual machine is booted up, you're good to use the Python. So what you like to do is to type simply Python and hit enter. So right now you have entered the Python coding mode. And you can basically say, hey, print something. Enter. There we go. In order to exit the Python, you would simply type exit and hit enter, and you're back to your Ubuntu environment. What I would like to do right now is to go ahead and talk about the app engine. If you remember from the video about Flask, Tatiana showed us how to create a basic web application. If you remember, she would run it locally. The app engine will allow us to do the same thing, but actually to deploy the web application and air it to the whole world. So let's say you have a project in mind you would like to do, and let's say you want to create a search engine for DAFA course. My partner and I created the skeleton for this, which looks like as following. What we actually did, we actually created the simple HTML file to basically reflect the skeleton we have here. And we also created the CSS file to actually make it look nicer. So here you see the HTML code that we used, and as well as the style. So if we run it on a compiler, the result would look as following. So we have the web page for the DAFA search, basically. We call it DAFA. However, right now it's running, you cannot access it from any device. You have to deploy it to the server. The Google App Engine allows you to do this. So in order to put this basic web application on the internet, what you would like to do is go back to Google Cloud Platform, go back to the dashboard, and find the App Engine by scrolling on the left bar. So here we have the App Engine. I would like to click on it. I'd like to create a new application. So here you'll have to select the region. So I'd like to select Frankfurt, which corresponds to Europe West 3. Click Next. Wait a couple of seconds until it sets up. So after the application is done setting up, you will see the following screen. What you would like to do is to actually go to Application Console, which is located here. So I'd like to click on Activate Cloud Shell. Click on Open Editor. And you would like to click Open a new window. So once the Cloud Shell has been booted up, the first thing that you would like to do is to go ahead and create a new folder where we're going to put all our files, including the Python files, HTML, and CSS. So I would call it DAFA search. Hit enter. So go into the folder and then create a new file. Call it main.py for Python. After we have created the Python file, I'm going to go ahead and create the folder called templates, where I will put my HTML file. So I'm going to create a new file and call it index.html, just to double check that the index.html is in the folder called templates. So here it is. I will also create a new folder called static, where I'm going to put my CSS file. I'll call my CSS file as style.css, hit enter. outside of this, where the main.py file is located, I will create another file called app.yaml, which is basically responsible for executing the app itself, YAML. And last but not least, the file called requirements.txt. So in the YAML file, I would go and say which version of Python the Google should use. So I would say runtime Python 3.9, hit Control S to save the changes, or go here and say save. For this web application, we'll be using Flask, and if I would like to specify which version the Google should use, I would go to requirements.txt and say Flask equals 1.1.2. As for this example, hit Control S and save. As for index.html file, the file which is basically responsible for creation of the skeleton of the project that we have in mind, because this is not the web programming course, I will not go into the details and explain how the code works. I will just copy and paste it in here. You can play around with it later. I will provide all the links to this code that we created with my partner. And I do the same for style.css, which is basically responsible for the fonts and the colors in the project that we have in mind. So I'm going to save both of these files and switch to main.py file, which is basically our Python file. What I would do in main.py file is basically the exact same steps that were nicely explained by Tatiana in her video about Flask. So I will just import the Flask itself. So I would go from Flask, import Flask, and also import the render.template. I would say app equals Flask name app.route I would define the function itself, def, let's call it page run. And inside the function, I would return the render date HTML page, return the render template, and I will say which HTML I am referring to. So in this case, it's index.html. I would exit the function and I would say if name equals main app run, save it. So at this point, we're done creating our first web application. The only thing that is left is to basically deploy the application to the Google server, and after that, receive the address which we can use to actually access our page. But before that, there is a small mistake here. We have to rename the requirement file, not the requirement, but actual to requirements. Otherwise, it's going to generate an error. So I do that, I save it, and I go gcloud app deploy in order to deploy our web application to the Google server. I hit enter. It asks if I want to continue. I say yes. So after Google is done deploying your web application to its server, you will see the following screen. The last step is actually to get the address to your app. What you would like to do is to go gcloud app browse and hit enter. And this will generate the HTTPS address to your web application. If you press on it, we are redirected to our project and we see the page alive. So it's got the actual address. Here are all the buttons that you can basically play around with. It does nothing, but this is just for illustration purposes. So at this point, our first web application is completed and is being available to the whole world. In just a matter of a couple of clicks, in a few minutes, we were able to get from this point where our web application would look like just a normal image to the point where we actually have our web application running on Google server and being alive. We can click a few buttons here and interact with the page. And moreover, we can even access it from the different devices. So in the presentation, there is a QR code which you can scan from your phone and actually access the same web page on your phone. I hope this presentation was somewhat informative. If any questions, please feel free to contact us.